Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Ashraf Biadanan. I will present about question 1. Question 1 is a transportation problem. For the introduction, the transportation problem is just a special type of a linear programming problem. We can take advantage of its spatial structure to adapt the simple algorithms and to have a more effective solution produced. Okay, for the answer, minimize any equation 1 equal 1 and j equal 1. For the subject, it is a diminution xe less than or equal to aj for j equal 1 and 2 plus m. For ay, attract that or equal to o for j plus minus 1 and 2, and xe is the quantity of transported from fraction in a warehouse j at a unit cost of cj. ai for the total supply from warehouse j, pj, and is a demand at outlet j. I will pass for next presenter.
Okay, my name is Muhammad Reza Izwan, and I will present the step 2. Step 2 is north to the west corner method. Like we see, we have F1 and warehouse 1, warehouse 2, warehouse 3, 4, 5, and supply. To all the costs, we have to multi each other. For 13 multi 150 plus 150 multi 9 for 100 multi 10 and 80 multi 11 and 100 multi 13, and the answer is 11,640 That's the answer for the step 2, and we provide to the step 3. Next. Okay, the least cost method. Like the sign of graph, we have F1, we have 1, 2, 3, and 4, and supply. The total cost is 20 multi 11 plus 130 multi 12 plus 250 multi 9 plus 200 multi 11 plus 50 multi 10 plus 70 multi 13 plus 100 multi 12 plus 130 plus 1 plus 10, sorry. For the answer is 10,000 60 140 40. Okay, next is conclusion. Thus, the transposition problem in Excel not only solve the problem but also help us to understand how the model works and what can be changed and to what extent to modify the solution, which in turn help to determine the cost and optimal supplier. Okay, that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Izzuan bin Fatia, and I will explain about question 2. So question 2, we will have the critical path method, CPM. So CPM is a strategy for determining schedule flexibility and identifying jobs that are required for project completion. In project management, a critical role is the longest series of operation that must be completed on time in order for the project to be completed. So in this question, we will determine the critical path. So at the table, we will see the path we get and we will identify is 6. So the total time from the path, we will plus it, or which is, for the example, A, B, C, D, G, H, M. So we will took every time from each activity and we plus it until we get the total, which is 40. So after we plus all of this path, we will choose the biggest total time, which is 44. So 44, the path is A, B, C, E, F, J, L, N. So A, B, C, E, F, J, L, N is the longest path in the figure or in this project. So the critical path is A, B, C, E, F, J, L, N because the activity completion time is 44 days. Long other than the other path. So we go to the table, which is not convention. So the not convention has, as you can look, will have the activity, duration time, early start, early finish, late start and late finish. So for example, the activity A, the duration time is 2. So the early start will be 0. And how to get the early finish? We will plus the early start and the duration time, which is 0 plus 2, we will get the early finish 2. So we can see the flow. We will go to the B. So it's same like the before, which is 2, we will plus 4 and we will get 6. And we move. Do we call this is forward pass? For early start and early finish is forward pass. So after that, after activity C, we will have 3 activity, which is D, E, I. So D, E, I, we will choose the biggest early finish. So as we can see, the biggest is 16 for activity C. So every activity, DEI will early start will begin with the 16. So after that, the flow we will go like before. D will go to the G, G will go to H and M and until finish. So after that, for activity F and activity I, we will before that after that we have activity J. So the early finish for activity F and activity I have a different time, which is 25 and 23. So for the early start for J, we will choose the biggest early finish from activity F, which is 25. So we will put 25 as early start for J. And after that, J will we go to K and we will go to activity L. And same like before, the early start we will plus with duration time for the activity and we will get the activity finish. So before go to the activity end, the activity end we will choose the biggest also from the previous activity. For early finish, we will choose 38. So N, early start for N is 38. So after that, 38 we will plus with duration time 6 and will be 44 until it finish. So this we call the forward pass. So after that, we will go look to the late start and late finish. I will pass it for to Afiq Aiman.
Thank you to Maizul. So now I will explain more about the backward pass that is need to find LS and also LF. So for the projects, the activity completion times we have is 44, and then we will bring the 44 to the date finish for activity N. So at the activity N, the late finish will minus to 6, which is the time, and we will get the late starts, which is 38. So at the activity N, the 38 will be bring to the late finish for both activity, which is K and L. So we will use the same method, which is we will minus the time, and then we will get the answer for the late starts. So as you can see on the slides, between activity K and L, we have identified two difference number, which is 34 and 33. So this is quite differ between the forward passes and different passes, because at backward passes, we will choose the smallest number. So we will choose the 33 as the late finish for the activity J. And then we will minus 28 until we get the answer for the late starts. So we will use the same method until activity A. So before we start, before that, the slack time is the how long the activity can be delayed without extending or increasing project completion times. So we have identified for the activity A, B, C, E, F, G, L, and there are no slack time, which is zero delay time. How we determine the slack time? We will choose between two formula, which is late starts will minus to the early starts, or we can choose the late finish minus to the early finish. So we will move to the last, which is conclusions. So for our questions, the critical path methods emphasize the relationship between applying moment or other resources to shorten the durations of given jobs in a project and the increased cost of these additional resources. I think that's all from us. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So, my name is Fahmi Muzammil bin Muhammad Saidi and my friend Muhammad Adam Haikal bin Adnan. So, we will present for question 3. So, the question 3 is about the linear programming. So before we go further, so the introduction for linear programming is in this topic, it can be used to find out for the best and the optimal solution in order for the problem, in order to solve the exist problem, and it will require the decision and set of decision about how best to use a set of limited resources in order to achieve the state goal of the objective. So the second slide is about linear programming, which is have two maximum problem and minimum problem. So for the maximum problem, the objective of the maximum problem is to find out the maximum profit of the equation. While for the minimum problem, the objective of the minimum problem is to find out the cost of the operation. There are 5 types of linear programming, which is product mix problem, which is MAX, blending problem mean, production scheduling program mean, transportation problem mean, and a flow of capacity problem, which is MAX. So we'll pass to the next presenter, which is Muhammad Adam Haikal.
All right, I will explain the answer of question 3. First of all, we decided that X and Y represent the toys of type A and type B respectively that has been manufactured in one day. So since the manufacturer state that he wanted to get a maximum profit, hence this is the maximum problems. First of all, since this is a maximum problem, so Z is equal to 7.5x plus 5y. That is for spatial equation. So for the subject to constraint, since the machine can produce the toys at the rate of 60 units per hour, so it must take 1 minute or 1/60 of an hour to produce a toy from the profit and the number of manufacturer toys per day. So first equation is 2x plus y equal or less than 60. We get that from the negative 12x from per 60 plus 6y over 60 less than 6. So next equation is also same formula we use that we take from the table. So after that, we get the equation 2, 3, 4, and 5, which is that's all the stated there. Next slide. Okay, after we get the equation, the feasible region determined by the constraints that is shown, which is all the region is connecting by the corner point of the feasible region, which is A, 20, 0, B, 20, 20, C, 15, 30, and D, 0, 40. So the value of the Z's at these corner points are as follow. So as we refer to the table and the corner point, C is the maximum of the point Z, which is 262.5. Hence, the maximum value of Z is 262.5 at 1530 corner point. Thus, and in conclusion, the manufacturer should manufacture 15 types of toy A and 30 toys of type B to maximize the profit. Next, I will show you the graph, this is the graph. All the connecting point of the corner point are shown is the graph. So the region that has been lored is the maximum point, which is Z. So in conclusion, the objective to find the maximum equation has been achieved by this question, such as example of this question. So many functional problems in operational analysis can be solved by using this linear programming. So that's all from us. Thank you.
Thank you.